So today we're going to be talking about solving systems of equations by substitution. For this first example, we've got x equals -4, which I'm going to highlight so that we know what's given from the get-go. X equals -4, and the other equation is 3x plus 2y equals 20. So the whole point of substitution is you want one of the equations to say y equals or x equals. For this first example, we already know what x equals, so all we have to do is substitute x equals -4 into the second equation. So if you see where we have step 2 in blue, it says 3x. Well, instead of x, I'm going to substitute -4 in there. So it says 3 parentheses -4 plus 2y equals 20. Then we just multiply 3 times -4, which gives me a -12. And then plus 2y equals 20. So in order to get y by itself, I need to add the 12 to the other side, because the opposite of a negative is a positive, so I'm adding 12 on both sides. When I do that, 20 plus 12 gives me 32. I bring down my 2y. Right now, 2 is being multiplied by y. So the opposite of multiplication, or the inverse, is division, so I need to divide by 2 on both sides. When I do that, it gives me y equals 16. So now where you see where it says solution, I already have my x. They gave that to me. So my x is -4, and then my y is 16. So in an ordered pair, you start with parentheses. The x comes first, and then the y. So that's why it's -416. The students can also check their work by plugging it in. So if you look to the right, all I did was plug in -4 in for x and 16 in for y into the bottom equation, and then multiplied that out. So 3 times -4 gave me 12, plus 2 times 16 gave me 32. When you do -12 plus 32, it gives me 20, and 20 does equal 20, so it checks out. So the first example was a lot easier than the ones to follow. So the next one, example 2, is y equals x minus 1. They give me that, and x plus y equals 3. So again, we're going to look to see if one of my equations says x equals or y equals. So in this case, the top equation says y equals x minus 1. So what I'm going to do is I'm going to take that x minus 1 in the top equation and substitute it in for y into the bottom equation. So if you look at step 2, the second equation, it starts off with x plus, so that's why it says x plus. Instead of y, I put parentheses x minus 1, because that's what the first equation says y is equal to, and then equals 3. Okay. When I do x plus x, that gives me 2x. I just brought down the -1 equals 3. From there, I'm going to add 1 to both sides in order to get x by itself. So when I do that, it cancels on the left side, and 3 plus 1 gives me 4 on the right side, and I just bring down that 2x. So then from there, I'm going to divide by 2 on both sides, and 4 divided by 2 gives me a positive 2. Now I told the kids, because I have x already, the top equation is going to be the easiest one to plug x into in order to figure out what y is, because it already says y equals. So if you look to the right side of where we just did step 2, on the right side of that line, that black line that I drew straight down, all I did was plug in 2 in for x into the top equation. So it was y equals 2x minus 1, but instead of x now, or it was, sorry, it was y equals x minus 1. So y equals x minus 1. So instead of having that x there, I substituted 2 in for that, because we found out that x was 2. So when you do 2 minus 1, you get 1. So then you write your solution out. You have both your x and your y. So as an ordered pair, x always comes first, so that's why the 2 is lifted first in that ordered pair. and then 1 is your y value that comes second. So that's why the solution is 2, 1. If we look at example 3, okay, they give me the equations 3x plus 2y equals negative 12 and y equals x minus 1. So clearly the bottom equation already says y equals, so we're going to substitute what y equals into that top equation for y. So that's why in step 2 it says 3x plus 2, but instead of y I'm going to do parentheses x minus 1, then close parentheses equals negative 12. Okay? Because I have a 2 and then a set of parentheses right there, I'm going to distribute that 2 to everything on the inside. So when I do 2 times x, that's where I got the 2x. And then 2 times negative 1 is where I got the negative 2. So that's how I distributed it. Then from there I combined like terms. So 3x plus 2x is going to give me 5x. I bring down the negative 2 at that point, and then equals negative 12. In order to get x by itself, I have to add that 2 to the other side. Negative 12 plus 2 gives me negative 10. Then 5 is being multiplied by x, so the inverse of multiplication is going to end up being division. So I divide by 5 on both sides to give me x equals negative 2. So once again, now we figured out what x is, so now we need to figure out what y is. I'm going to use that second equation because it already says y equals. Okay, so all I have to do is plug in negative 2 for x. So it says y equals x minus 1, so y equals, instead of x now, I'm going to do negative 2 minus 1. And when I do negative 2 minus 1, that's going to end up giving me negative 3, which is my other solution for the ordered pair. So when I write my solution, once again the x comes first, so x is negative 2, and then the y comes second, which is negative 3. So negative 2 comma negative 3. Okay. If we take a look at example 4 here, in this case they both have x equals. The top one says x equals 2y minus 7. The bottom one says x equals 3y plus 6. Because they're both the same variable that's isolated, all you do is set the two equations equal to each other. So step 2, I took the bottom one, 3y plus 6, and set it equal to the top one, which is 2y minus 7. Okay. Then from there, all I do is start trying to solve for the variable, which in this case is y. So I like my variables to stay positive, so that's why I subtracted 2y to begin with, because I know when I do 3y minus 2y, it's going to give me a positive y. And then I brought down the plus 6 equals negative 7 from there. And the 2y's cancel after I, on the right side, because 2y minus 2y just cancels out. So then from there, in order to get y by itself, I need to subtract 6 on both sides, which is what you can see from that point. So when I do negative 7 minus 6, that's going to end up giving me a negative 13. Okay. So what I did, the kids asked me to plug it into the bottom equation. It doesn't matter which one because they both already say x equals. So the bottom one, x equals 3. Instead of y, I'm going to plug in negative 13 in for that and plus 6. When I do 3 times negative 13, I get a negative 39 plus 6. And then when I combine negative 39 plus 6, that gives me a negative 33 for my x. So that's why, as the ordered pair for the solution, negative 3 is my x. So it comes first, and then my y is negative 13, which comes second for that. So that's how substitution works. If they already have an x or a y already solved for, all you have to do is substitute it into the other equation in order to get the answer. So hopefully this helps me talking through the examples so that the kids can not only see it visually but also hear me talk through the process at the same time. They will have a quiz on Tuesday or on Friday over substitution and elimination. So hopefully they can look back at this and that'll help them prepare for their quiz on Friday. Thank you for your time.